Good afternoon, Nana. Myself is Mr. A Suryawanshi. My research topic is that implementation of block cipher techniques to enhance the performance of mobile communication networks. In this case, for the billion of people are using the mobile phone on a daily basis. The mobile has evolutions from first generation, second generation, third generation, fourth generations, and in this the fourth generation system is expected to provide a comprehensive and secure all IP-based mobile broadband solutions to users through wireless modems as well as through smartphones and other mobile devices. In this case, the mobile services have many commercial utilizations and functions such as the internet network, the service electronic banking, messaging networks, electronic mails, smart cards, WW servers, and automated teller machines. So while sending this information safety is very important objective for all these services for the citizens as well as for the military applications. Some of the GSM weaknesses are cryptographic techniques the short cipher key is to be used. So in this case, considering the need of security in the information, the cryptography concept has been introduced. So cryptographic technique, in this case, the cryptographic methods are utilized for the authentication, privacy, data confidentiality and data integrity. While designing few parameters of these algorithms need to be considered, that algorithm should have a high speed, minimum utilization of hardware resources, latency, the power consumption and the frequency. So for our research for authentication, for confidentiality, for data integrity, I have chosen the three cryptographic block ciphers, namely advanced encryption standard, then second one is that the Selifia, and the third one is that the Kusmi. Mostly in the mobile communication networks there are some security issues. These security issues are as a access control. In this access control, the access will be given to the users for limited sources, and which is defined in terms of that access control list and the closed network. In the security, second issue is the authentication. While in the authentication, the communication from one node to the other should be genuine. It should be genuine. So only the legitimate persons can access the systems and services. The availability. It indicates that service offered by the node will be available to its users with expected in spite of attacks. Integrity. This integrity, it indicates that though we are sending the information, that information should not be modified by the third person or the intruder. So that's why the integrity is very important. The non-repudiation, it ensures that the origin of the message cannot deny having the sent messages. The confidentiality, it ensures that the carrier information is never disclosed to the unauthorized persons. So this information, it may be personal or sensitive data, is to be protected through the confidentiality. So in this case, there are some literature review of AES. My main aim of the research scope is that in the UMTS standard, for the authentication, confidentiality and integrity, they have used the Legendre algorithm as well as that the Kusmi. But I am proposing the three different algorithms as a Selifia, Kusmi and AES for the different operations of that the authentication, confidentiality and integrity. One more thing is that while designing these three algorithms, we should take the care of that the attacks has been occurred on these algorithms, and the attacks, how much time needs to be taken by the attackers to attack on this algorithm. Before that, the data should reach towards to that the output. That is my main aim in this research work. In this case, the literature review of AES is that the AES has been implemented in different ways, in the feedback logic method, in the pipeline method, round pipeline methods. Whereas the Kusmi has been also implemented in feedback pipeline, and that is for the Selifia. When I go for my first algorithm, that is the Selifia. The Selifia is using that the key whitenings. in the block cipher, key whitening is a process where it will secure the block cipher. And in the key whitenings, we are using the generalized keys before the encryption and after the encryption, so that the attacker cannot break the block ciphers. So Selify uses the four branch generalized crystal network, and there are also the 8 branch generalized crystal network has been used by the Selify. Selify is having 128-bit data with the 128-bit key, 192-bit key, and 256-bit keys. There are two processes in the Selify. One is the data processing part, and another one is as a key scheduling part. This is the general diagram. This is the algorithm. So main diagram of that the Selify. In this case, the whitening keys are used here at the start of the process. Then it is applied to the FO function. Then the second, the F1 function. The major two blocks are FO and F1. When we go for the FO functions, in that FO functions there are two boxes. One is that the substitution box, and another one is as a matrix box. The substitution, it indicates that it is a SPN network, that is substitution permutation network, which will increase the process of the confusion and diffusion principle. So confusion depends on the substitution, the diffusion depends on that the permutation, so that the attackers cannot modify our algorithm. That's why the substitution permutation networks, SPN networks, are to be used here. In this case, my main aim in this case is that the design of that the MG, the first design of this in this research is that I have modified the S0 blocks. While taking that the S0 blocks, the initial inputs to the S0 box is X0 and the initial key. Then this S0 output is applied towards to that the M0. While designing this S0, if the S0 value is a substitution box, it is a 4-bit linear box which uses having the 21 is the answer and A1 is the, if I take the 21 value, my answer should get as a A1. So that design I have done through this substitution box. Now in the second design of the Selify is that I have taken the, by thoroughly studying this Selify block cipher, which is using the diffusion switching mechanism. The one most important component in this Selify is the M0 matrices and M1 matrices. When the data comes from that the F0 from the substitution boxes, that data is applied to these M0 matrices. Now what I thought that while this multiplication depends on the Gaussian field, and this Gaussian field is using the primitive irreducible polynomial. So the first one is that the first T1 it will be the 21 into 01, then 02, 046 and 06. Now this matrix, this M0 is a fixed matrix where the multiplication components are also fixed. The first multiplication component is 01, 02, 04 and 06. So while you are using the Gaussian field multiplication methods, actual process starts here is that you have to write the number 21 into 01, take that 29 in terms of that the binary number, then convert it, and after that converting, make all these numbers in XOR logic and then go for that you will get the T1 result. So while doing that, now what I am thinking here is that the multiplication by 2. The multiplication by 2, that let us take that the matrix is fixed for 2 number, 4 number, 6 number. So while I have designed the multiplication by 2 like this way, like B of x is equal to B0, B1x, B2x, B3x, like this series for the 8-bit number, because the initial data is also 8-bit. So by multiplication by 2 is taken by just as a x, because the numbers which are starting as a x cube plus x square plus x plus 1, which is an irreducible polynomial. Just multiply by x, you will get b0x, b1x square.
Okay.
Then just
go into derivation. You please go.
Now by designing this, instead of using the Gaussian field multiplication method, instead of using the shift and add method, which will get the more complexity and more time, I have designed that the multiplication by 2 you can do by only using the 3 XOR gates. Similarly, I have proceeded for the multiplication by the 4 as well as by the 8, and this same I have implemented in the Selifia algorithm, and the Selifia speed has been increased. Now this is for the multiplication. In the Selifia we require the constant values. Selifia for 128-bit data, for 128-bit key, Selifia requires 60 constant bit values. In these constant values are generated simultaneously, because due to the diffusion mechanism, the algorithm's security should be increased. So for that purpose, the constant values are used here. Now the key also is to be generated simultaneously. The key is using the constant values for 12 rounds of that, the 0 to 24. First take the initial key, consider as a whitening keys, then generate the intermediate key L. This intermediate key L is generated by using the generalized Fistel network as a 4x12. Whereas this generalized Fistel network, where one output goes for 2, 2 goes for 1, 3 goes for 2, and 4th goes for that, the 3. So while
the strength of this will be as strong as generalized Fistel network.
No. The keys are generated using the generalized Fistel network, and it is a 4.
Strength for that will be the same as that for.
No, because the strength every attackers will try to attack on the key. So the key should be very strong. So the key should be generated by, first of all, taking the initial key, give towards to the generalized Fistel network, operate for the 12 rounds, generate the intermediate key, then intermediate key will be XORed with the constant values, that the 4 keys will be generated. Then second key, the double swap function. In the double swap function, whatever the intermediate key you got, that intermediate key should be taken from MSB to LSB. Then in that 7 to 63 should be there, the arrangement in the key, and then 121 to 127, then 0 to 6, 64 to 120. That is the double swap function. Then this will be again multiplied with initial key, XORed with initial key, again XORed with the 4 constant values. That these keys are for the next round keys. So like that way.
You have a plot of the number of statistical number of instances and then the key values which are there.
Yes, I have implemented in VHDL.
Is there any collision of these key values? Have you observed any collision of the key values?
Collision?
Same key value.
No. Because
how many instances? No.
It will be operates for the 18 rounds.
If you write a program, let it generate one generating millions, and then only you can observe and say.
Yes. So I have this. I have the results also, which are.
You have those simulations.
Yes. I have with my simulations in the VHDL. So now the next I have taken the hardware implementation of AES, this advanced encryption standard. The key scheduling generation of the AES is that take the initial key, and that initial key is to be mapped. This initial key is to be mapped. This initial key is to be mapped in the 4 rows, 4 columns. Take the final round, rotate it, then implement the S box, and then implement the Archon register and multiply with the first rows of that, the first column of these. Then it will generate the first initial key for the first column. So in this case, the encryption process will be starts by the 4 methods. One is that the add round key, the second one is that the substitution box, then third one is for the shift rows, then fourth one is that the mixed column, and the fifth one is that the shift rows. In the shift rows, when you are applying the substitution box, the 128-bit data will be applied. This will be applied for the substitution. On this 128-bit data, the substitution box is applied. Then we have the shift rows. The first row will be cost same. The second row will be left by 1 bit. The third row will be left by the 2 bytes. The fourth row will be left shifted by 3 bytes. So like that way, the data this will be shifted by 1 byte. So BF will comes to the 27, and 27 will move towards to the position of 41. So like this way, shift rows operation will comes, and after that, the mixed column transformation is to be implemented. The mixed column transformation is totally depends on the Gaussian field, and this is a fixed matrix through this multiplication you will get some D0, D1, D2, D3 values. Again same 128 bit data will be carried out. Now in this mixed column transformation, the multiplication will be done by using the Gaulish field method. So now when I gone through this research work about that the Gaulish field multiplication, I came to conclusion that the implementation of that the yes box, implementation of the mixed column can be done by, instead of using the shift and add method or using that the Gaulish field method. In this case, the mixed column transformation for the AES contains this matrix. When we see that in this matrix there are three elements which are going to multiply with
Do
it.
you have any proof?
Yes, sir, I have proof.
Is there a theoretical proof?
Yes, sir. Yes. Just to the next slide, sir. Just
So theoretically you are doing the
yes, just next slide. Now in this case, this R0 is there. This R0 is 02 into D4, 03 into DF, and 01 into 30. Just I will show for the R0. Then similarly R1, R2, R3, and R4. Now for this R0, the multiplication by 2. While multiplying the 2, just take that the initial number, shift it by 1 bit, pad with zeros. Then conditionally you can XOR with the 1B bit number. Let us take that I have the number 02 into D4. I want to multiply with D4. Write that D4 in terms of binary number 11010100. Check that numbers MSB bit is 1. Yes, if it is 1, shift it by 1 bit and pad with zeros. If I shift with that 1 bit, then I will get 1010 1010 because the number is paired with 0. Now the conditional XOR with the 1B, that is 10001, B is 1011. Why? Because the polynomial which is given in the Gaulish field is x to the power 8 is equal to x to the power 4 plus x cube plus x plus 1. Now after that I will get this answer. Now multiplication by 3. Instead of going separately multiplication by 3, I can use I can take the help of multiplication by 2. Generally we write 3 number as a 1 1. Then this 1 1 can be 1 done. To obtain this 1 1, I can make a XOR of 2 and 1. So I will get this result. So again the multiplication by 2 with the same result, and the multiplication by 1 again the same result. So after that the conditional bitwise XOR operations, the operation has been performed, and by the 2 bit, by the 2 number and 3 number, and for the multiplication of 1 is the same number will take place. So lastly, sir, the R0 numbers value is 04 in hexadecimal. Same I have implemented in the hardware architecture. So that's why the complexity of the mathematical multiplications by the shift and add method or by using the Gaulish field method to increase the processes, the time consumption will increases. So definitely it will decrease the time of that the process of the mixed column transformation through this hardware diagram. So the hardware diagram for this I am presenting here, and the results also I am showing with the AES. This mixed column I have implemented, I have given to the AES, and the results I have obtained. Now one more thing is that the shift rows operation also can be without using the multiplexer, without using that the logical gates. We can use only simple OR gate for the shift rows, for the performing the functions. Now the hardware, now the S box. In the AES, S box is a heavy nature. To implement this S box for the AES, it is having the it can be implemented through the combinational logic as well as it can be implemented through the read-only. Okay, so now in this case I have implemented the S box of the AES and the squaring, multiplication, constant with lambda, then S box design. The output also I am going to show. Then again I have taken my third block cipher, which is the Ghrce. This Ghrce block cipher also implemented. In this case, this is the Ghrce block diagram. This total diagram I have implemented with the feedback logic, so that it will reduces the hardware and it will be useful for the compact disk. So now when I come to the logical gates are in Ghrce, this is my logical diagram for that the Ghrce. Instead of using the large data, I have just used that the 4 multiplexers, and through the 16 clock cycles. In between that the 16 clock cycles, I have got the results. After implementing all these things, I have these results which I have compared with the other researchers. Then my results of the mixed column with the other two methods, and this is for the implementation of Ghrce, this is the implementation of pipeline, and for this at the end I conclude that these three block servers which I have implemented for the high speed, which are in compact in size, are useful for the authentication purpose, for the confidentiality purpose, for the data integrity purposes. Also, I can recommend that these ciphers are very useful in the ITS as well as for the in the implementation of that the automated teller machines, small embedded devices, smart cards, RFID tags. So it will improve the performance of mobile connection.
So, I could not observe any publication of this communication.
Myself publications?
Where I did not see any publication.
मैंने नहीं डाला है publications से 5-6 publications आ रहे मैं नहीं है क्या सर?
Why it is not shown?
I have publication just now.
For thesis submission, one journal paper, 2 conference.
Yes, I have. Sir, I have written a book chapter for this next generation wireless sensor methods for my guide. So this is the.
Okay, fine. Okay. But you must always include the submission.
Yes.
That is a.
Yes, sir. I have
always good. So always good to use the list of
certificates और वो जो दिया था
हाँ है. It is.
and these days the thesis submissions.
Yes.
You have to run it through the similarity check.
Okay.
Okay.
So I have published in.
But one thing I wanted to say, you have only given a demonstration. It is not acceptable as a mathematical. It is not a mathematical. That is only a demonstration. It is not.
No. So I have result.
Mathematical proof is different. It is much beyond your this one. Value field theory and those kind of things. There are more advanced mathematical things are needed for this kind of things. Other important point is that now, what is the relevant comparisons, literature comparisons and all that, that is also required to be given, shown systematically. Okay? So that also you can see that.
Okay. Thank you.